to the few of you that are here. Maths. We did lots of maths this weekend and the previous weekend. Um, Most of you did like a mixture of maths questions and stuff. Um, and yes, I absolutely can. Hi. Most of you did a mixture of lots of math questions. These were not easy maths questions, I will warn you, so I'm more than happy to help with a lot of them. Um, Essentially, this was a booklet that you would have done nearer the end of the year, but we just brought it forward. And so, yeah, don't worry if you found some of it quite challenging, but that's why we're here, to practice this. I think booklet one and booklet two were the same as well, which is quite helpful. So I will go through the questions that have been asked so far, which are relevant to one and two, I think. So 1, 2, 14, 12, 10. 1, 2, 4, okay, 1, 2, 10, 12. Okay. One um, says, look at the triangle. And it asks you to work out the value of A, booklet two. And what I'll do is I'll go through all of this booklet, which is all of booklet one and two, as in it's the same booklet, if that makes sense. So we'll cover all of the questions that anybody has got. So, question one on here says, look at the triangle and work out the value of A. Okay, the value of A can't be done actually without working out the value of B. It's quite complicated. So what we need to do is look at this triangle here. You should know that the three angles inside a triangle add up to 180 degrees. You should also know that this angle here is 90 degrees. So let's write down what we know. We know that this angle plus this angle, 2B add B, plus this angle, all three of them added together, makes 180 degrees. 30 degrees. Okay, you give me the answer. So these two add up to 3B. If you simplify, because you've got like, two bananas plus another banana, is that. Then this becomes a solving equation question. We did a lot of solving equations at the beginning of the year, right at the beginning of the maths that we did. To solve this equation, what you would have to do is subtract the 90, because it's an add on this side, it's a minus on the other side. 180 take away 90 is 90. And then to find out what b is, we would move this 3 by doing 90 divided by 3. And 90 divided by 3 is 30, which means that is what b is, but that doesn't answer the question of what a is. So since b is 30 now, what we can do now is do some other stuff, which is look at this. You should hopefully know that there is a rule about straight lines and angles, which is the two angles next to each other add up to 180 degrees. So if this one is 30, this one is 150, so that these two add up to 180. Okay, then we start looking at this triangle on the left. Once again, all three of those angles should add up to 180. So what do we know? We've got a 150, we've got an A, and we've got another A. All of these add up to 180. What do these two A's make? Well, they make 2A. Okay, and then what we'll do is very similar to what we did on the other side, is I'm going to take away this 150. That'll leave me with 30. And then I will divide by 2. 30 divided by 2 is 15. And A ends up being 15. Is A 15? Yes, it is. Yeah. Okay, I'm going to keep going. Question two. Once again, I will make it clear, these are not easy questions, okay? So let's just not, worry about it too much. The diagram shows a rectangle, right? As soon as you see the word rectangle in a question, remember what you know in terms of angles, which is that all of the angles inside here are all 90 degrees, right? There's also it touching an equilateral triangle. Okay, let me just talk about equilateral triangles. An equilateral triangle is a triangle where all three sides are exactly the same length. It's just perfect, like a perfect triangle. But what that tells you also, more importantly, is that all of the angles inside an equilateral triangle must be 60 degrees, because 60 add 60 add 60 is 180, and they're all the same. So the thing I know here is that this angle is 60, for example, and that this angle is 60, and that this angle here is 60. Okay, so I know all of this stuff. Right, then the question is, work out the size of this little thing over here. Well, there's a lot to think about here. We have here a straight line, okay? And this angle next to it these two have to add up to 180, because that's the rule about straight lines. So if that is 60, this must be 120. That makes 180. And then what we'll do is we'll look at this triangle here. Okay. The three angles inside that triangle have to add up to 180. So we've got 120 already. 20, that's 140 so far, which means that this must be 40. Okay, so that's 40. Nearly finished. Didn't actually need that 60, but anyway, I'll leave that for a moment. There is a straight line here again, and there are three angles on this straight line next to each other. We've got 40, this 90, and this x. So that 40, that 90, and that x must add up to 180, because it's a straight line again. Lots of things in angles add up to 180. What do these two add up to? 130. And so this missing number must be 50, right? Because 130 plus 50 is 180, or you can do 180, take away 130, and you end up with 50 there. And that's how you do that. Not an easy question. These are very challenging questions. Now everything has changed. The rectangle touches the equilateral triangle, so the ABC is a straight line. So they've just moved it a little bit. As you can see, they've moved it a little bit. Sort of made it all touching. And the question is, show that triangle BDE, which is this one, is isosceles. What does that mean? An isosceles triangle is a triangle that, I mean, if I exaggerate it, it looks like this, where these two sides are the same length, but the third one is different. And when that is the case, the two angles at the bottom here will be exactly the same. So if I want to show that a triangle is an isosceles triangle, I need to show that two of its angles are exactly the same as each other. That's what I'm trying to do. Okay. So this is BDE. What I need to do somehow is show that two of the angles inside this red triangle are exactly the same. How will I do that? Well, once again, we know I've got a rectangle here, right? So remember, all of this is 90. If I need it, that's 90 as well. This was an equilateral triangle, remember? And I told you about equilateral triangles, that the angles are all 60 degrees inside those. So that's 60, and that's 60, right? Since I know this is 60, just like before, I know this is 120 because there's a straight line over here. Now here, there is a straight line as well. So these three angles, the 90, the 60, and this little one, make 180, don't they? So 90 add 60 is 150, which means this little bit is 30 degrees. So they all add up to 180. Now I can work out what this angle is because these three angles have to add up to 180 inside this red triangle. I've got 120 plus 30 is 150. And this third one to make 180 has to be another 30, doesn't it? And so what I have done there is shown that this angle and this angle are exactly the same. And that makes it an isosceles triangle. It is only an isosceles triangle if two of the angles are exactly the same. Booklet 3 I will do after I've done this one. Okay, it's just going to take a little bit of time, but I will basically do nearly all of booklet 3 because I know this was difficult. This question. A room has white balloons, pink balloons, and yellow balloons. This shows the probability of each color being chosen. Work out the value of X, which is the probability of choosing a pink balloon. The thing you need to know about probability is that if you know all of the probabilities of something happening, then they add up to one whole. Okay, just like if I toss a coin, I can get a heads, which has a probability of a half, and a tails that has a probability of a half. Those two add up to a whole. The same applies to any situation. If you add up all of the probabilities, it has to add up to one. So these three have to add up to 1. So 0.6 add x, add 3x have to make one whole. Now these two make 4x. Then I can take away 0.6. 1 take away 0.6 is 0.4. And then I can divide by 4. As you can see, as you do slightly harder math questions, you must work on this kind of thing, like rearranging equations, because it's kind of every topic is this. And x, therefore, is 0.4 divided by 4, which is 0.1. Very good. And that is that. Use approximations to estimate the value of this. This is the kind of thing you will get later as you guys are different ages at the moment, but you will start using a calculator more and more and more. But you are most likely to end up having an exam in year 11, which in which one of the exams you don't have a calculator in it. And in that kind of exam, you do get questions like this, where they say, work out the answer to this thing, but use approximations. That means make the numbers a bit easier for yourself. We don't want the exact answer to the question. We just want an estimate. So roughly what is the answer to the question? Um, and you basically do that by rounding your numbers to something nice. Like, for example, that can be 20. That can be 300. And that can just be 40. We'll just round it like to the nearest tens, basically. Um, and then it becomes a bit easier to do because 300 times 20, I know, is 6,000 because 3 times 2 is 6, and then there's three zeros divided by 40. And even 6,000 divided by 40 is not terribly difficult to do. When you are dividing two numbers and they both end with zeros, you can cross out the same number of zeros on the top and the bottom from the end. So rather than do 6,000 divided by 40, this has become 600 divided by 4, which is a little bit easier to do. Now, you could do 600 divided by 4 using, hopefully you are familiar with a bus stop method like that. Or, let me show you a little trick. If you are dividing any number by 4, if you half it, in this case, half of 600 is 300, and then half it again, half of 300 is 150, that is the answer. Got somebody else said here? 150, yes. So just remember that for dividing by 4, if you're trying to do it quickly in your head, try it by halving and then halving again. So like, think of an example. Um, no, I can't think of a difficult example. But yeah, 120 divided by 4, that's not a difficult example. But if you halve 120, it is 60, and halve it again, it's 30. So 120 divided by 4 is 30. Just try to remember that. Um, and luckily, you have the same question twice, so I need to go over that, do I? Work out this question. I will do this quickly because I would assume that you are, yes, questions 4 and 5 are the same. That is, just 3 marks for you, or no, or fewer marks if you get it wrong. 2 3/4 divided by 1 1/5. If you are doing, whenever you see these things called mixed numbers, you should turn them into improper fractions. You do that with this by timesing 2 by 4 to get 8, add the 3 at the top to get 11, and it becomes 11 divided by 4, or 11 over 4. Do the same with this, and that becomes 6 over 5. When you are dividing fractions, you have hopefully had the phrase keep, flip, change perhaps ingrained in your mind, where you keep the first fraction, you flip the second fraction, and you change the divide to a times. And you then do it the multiplication question, where you just do 11 times 5, 55, 4 times 6, 24, and you can leave your answer like that. You do not need to do anything else with this question. Like turn it back to a mixed number. You do not need to do that. Right, I can understand why question 7 would be a challenge here. Write the values of K and M. Well, the best thing to say is, the easiest way for me to explain this question for now is to go, well, I'm trying to make 64 every time. 8 squared is 8 times 8. That's why we put equals 64. Now I need to figure out how many times I need to multiply 4 by itself to get to 64. Now 4 times 4 is 16, so that's not 64. Times another 4. 4 times 4 times 4 is 64. In other words, there's 3 of them. So that's 4 to the power 3. So this k is 3. So that's why that's that. Similarly, I need to do the same thing with some 2's. I need to do 2 times 2 times 2, etc. Keep going until I get to 64. So that's 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64. So this is 64, and that is 2 to the power 1, 2, 3, 4, 5, 6. So this little m is 6, and that's it. Let me actually know let me see if people ask this question. Let me know what the answer to this question is. Question was 7 mentioned at the beginning. 7b was mentioned. Right, 7p. Right. If I showed you 2 to the power 2, the answer is 4. Okay. And I showed you 2 to the power 3, the answer is 8. If I showed you 2 to the power 4, the answer is 16, because you keep times by another 2 each time. 2 to the power 5 is um, 32. Right. Now, let me just show you something on the calculator. 2 to the power 10 is 1024. If I now asked you what's 2 to the power 9, I'm hoping you can figure it out, because what's happening every time you go down is that you're doubling, aren't you? You're timesing by another 2, timesing by another 2, timesing by another 2, timesing by another 2. Similarly, you would have times by something by 2 to get to this 1024. So now to get to the back to that, you would divide by 2. 1024 divided by 2 um, is 512. So in other words, what they're asking you in this question is whether you understand that that 2 to the power 14 must be half of 2 to the power 15, because we doubled from here to get to here, so we must halve now. So if I do 3, 2, 7, 6, 8, and divide by 2, 2 goes into 3 once, remainder 1. 2 goes into 12 6 times. 2 goes into 7 3 times, remainder 1. It goes into 16 8 times. And it goes into 8 4 times. 1, 6, 3, 8, 4 is half of 3, 2, 7, 6, 8, which is what 2 to the power 14 must be. Must be half of 2 to the power 15. Splendid. Nobody asked for question 8. I'll speed up on this. Oh, okay. 10. And then the last few, 13, 43. I'll do 10 onwards. Right. The height of this cuboid is 4 centimeters. The volume is 100. Work out the area of this. Well, just to let you know, again, you may not have done too much of this, but we did do a topic on area and volume a little while ago. But, oh, did we? Yeah, we did a while ago. But you might have forgotten. The idea of this is when you have these like three-dimensional shapes called prisms, there is a quick special way to work out their volume. The volume is how much space there is inside them. And that is that you work out the area of the shape at the front, in this case, this rectangle, do that times that, and then times it by how long the shape is. So you work out the area of the front and then times it by how long it is. So if I wanted the volume of this shape, I would find the area of this, let's call it A, and times it by how long the shape is. So A times 4 would give me the volume of this shape. But they've told you the volume is 100. So if the volume is 100 and I've got something times 4 is 100, then that something has to be 100 divided by 4, which is 25. And that is why the answer is 25 for that question. The volume of another cuboid is 100 centimeters. None of its dimension is 4. What dimensions could it be? So here is a cuboid. To work out its volume, I would take this number, this length, times it by this length, and then times it by this length. They've told you its volume is 100. Basically, they're asking you what three numbers could times together to give 100, but you can't use 4. That's what they're saying. You can't use 4, but use anything else. So, I mean, you literally could do 1, 1, and 100 if you really wanted to, because 1 times 100 is 100, isn't it? You could have done 2, 2, and 25. That would also have worked. Um, yeah, that would have worked. 2, 2, 25. You could. There's quite a lot of other combinations as well. Um, 10, 10, and 1 as well would work, I assume. 10 times 10 times 1 is 100. So three numbers are times to give 100, of which none of them are 4. You're not allowed to use 4. Okay. Um, and then this one, a prism has a cross section with a right angle triangle. Its volume is 100. What could the dimension of this prism be? I think this one's a little bit harder, but because it's effectively half of this shape, you just need to halve. Oh no, in fact, you need to do, oh God. Quite a complicated question. I'll give you one of the answers. In fact, I'll just check. What is 10C? What options does it give? Yeah. I won't explain that one, but it's a bit complicated because it's to do with the area of a triangle, and because you do a half times the base times the height, you have to make everything slightly bigger, because you end up halving it. So that's it. You need three numbers at times to give 200, basically. Any three numbers at times to give 200. Okay, question 11. Find the values of A and P. I mean, this should be easy enough. When P equals 10, take the number 10 and put it in there. Right. So if you put it in there, this says 3 times P is now 10 cubed over 2. Now, 3 times 10 cubed means 3 times 10 times 10 times 10, which is 3,000. 3,000 divided by 2 is 1,500. Done. This one, if P is 10, then on the bottom we've got 7 times 10, which is 70. Wonderful. On the top, we've got this. So in this bracket, we've got P take away 3, which is 10 take away 3, which is 7. And then we've got 2 times P squared. If P is 10, then P squared is 100. 100 times 2 is 200. So we've got 200 times 7 over 70. 200 times 7 is 1,400. And then, like I said earlier, when you're dividing numbers that have zeros at the end, you can cancel out the zeros and make it a bit easier for yourself. 140 divided by 7 is 20. This one, I should tell you what you do here. There is a C on the top and a C on the bottom. It can cancel out. In fact, I'll do a long-winded explanation here. On the top, we actually have 3 times C times D squared, which is D times D. On the bottom, we've got 5 times C times D. They're all being times when they're stuck together like this. And what you can do is you can cancel out that with that, and you can cancel out that with one of the ones at the top. So now, and there's nothing else you can cancel. So on the top, you can have 3D, and then on the bottom, you can just have the 5. And that is what we mean by simplify. That would be enough. Multiplying these out, I will just do these quite quickly. Again, it's good to practice these, but you just have to be very careful with minuses when you do these. So when you have a number outside a bracket, you have to times that by everything inside the bracket. So 3 times x is 3x, and 3 times minus 2 is minus 6. Then we've got minus 2 times 4, which is minus 8, and minus 2 times minus 3x. The minus times the minus makes a plus. 2 times 3x is 6x. And then what you would do is you would add these together. 6x add 3x is 9x. And then add these together, or in this case, minus them. Minus 6 take away 8 is minus 14. That should be the answer. And then this one. When you're expanding two brackets that are next to each other like this, you've got to make sure that everything in one bracket is times by everything in the other bracket. So that's that one, and then this one has to times by that and that as well. So you get 4 multiplications. X times x is x squared. X times 3 is 3x. 2 times x is 2x. And you add them all together. 2 times 3 is 6. And there's usually something in the middle that you can simplify. 3x add 2x is 5x. And you've done it. This is the same thing, but I'll just do it. A lot of these, aren't there? X times x is x squared. X times minus 1 is minus 1x. 4 times x is plus 4x. And 4 times minus 1 is minus 4. The only thing to be careful of is all the minuses. Minus x add 4x is 3x. It's like 4 take away 1. And that becomes the answer. When you have a squared, what does squared mean? It means multiply it by itself. So I've got a bracket. I need to multiply it by itself. And then you do exactly what I did in the previous question. And you will end up with x squared minus 4x plus 4 as the answer. Oh, this is horrible. I assume this was asked. I remember doing this earlier. Yeah, 12. A child is having a bath. The simplified graph shows the depth of the water in the bath. Right, let me explain what's going on here, because it does take a bit of understanding here. We have turned some taps on. In fact, from A to B, both taps are turned full on. Right, we've turned the taps on. So what does that do to the depth of water in the bath? It starts to increase. There's more water. Should we do it in blue so there's more water-like? Yeah. So the level of water is rising. It's rising. Then something changes where it's still rising, but it's not rising as quickly, right? When you have a steep line, it's rising really fast. So something's changed now because you see how it's just bent slightly. Something has changed, right? The thing that has changed is the answer to part A. From A to B, both taps are turned full on. What might have happened at point B? Well, the clue is in the both taps. If it's now going up but a bit more slowly, maybe we've turned one of the taps off. That could be the answer, right? One tap is turned off. Then at C, sorry, we seem to now, the level of water in the bath seems to stop increasing. That to me suggests we have turned the taps off, okay? In readiness for somebody to enter the bath. And then D to E is weird because it jumps straight up. Why does the level of water just suddenly jump up? Well, if you've ever got into a bath before, the level of water just goes up as soon as you go in because you take up the space of the water and it sort of pushes it upwards. So D to E must be the person getting into the bath. And then E to F, they seem to have a bath. So the level of water doesn't change. Right. At F, they've decided they've had enough. So we'll get out of the, well, what we'll start to do now is we'll start to what's the word? Unplug the thingy in the bath, right? And what will that do to the level of water? It will start to decrease. And then suddenly it decreases really fast. That to me suggests that the person has got out of the bath, right? The only reason some of the water suddenly goes up or down is the person getting in or out. And presumably when they get out, it's still not empty. And so it continues to drain, and then we come to a stop. So that is understanding everything that has just happened in that journey of that bath. Which part of the graph shows the child getting into the bath? Well, as I said, this vertical bit, D to E, is the bit where they're getting into the bath. The bit where they're getting out of the bath is here, G to H. That's why it drops so quickly. And that's it. I need to move on, don't I? All right, I'll do the last question from this one, and I need to move on to number three. 12 and 14. It's 12, I've done 14. There's the last one I'll do from this one. Um, a triangle has three sides that are 13, y plus a, and 3y plus 1. It's isosceles. What could the length be? There are three different answers. Oh, jeez. Right. If it's an isosceles triangle, two of the sides are the same, and one of them is different. But we don't know which way round they are because we don't know what these things are. So let's pretend that this is 13, this is y plus 8, and this is 3y plus 1. Okay, so let's pretend that's the case. If that is the case, then this and this are the same. Okay, they must equal the same thing. And if they are the same, then y is 13 take away 8, which is 5. And so if that is the case, one thing could happen, which is that one of the sides is 13, one of the sides is 5 plus 8, so another 13, and the other side is, if y is 5, 3 times 5 is 15 plus 1 is 16. So that's one option. Okay. But what if these two are the other way around? So if this was over here and this was over there, if that is the case, then these two are now the same. So 3y add 1 is 13. Let's solve this. If we take away 1, 3y equals 12, and y equals 12 divided by 3, which is 4. So in that situation, one of the sides is 13, the other side is 13, but this side is 4 plus 8, which is 12. So that's one option. That could be true. But then there's a third option, which is that 13 could have been down there. So if the 13's down there and the y plus 8 is there, then these two are the same. If those two are the same, then y plus 8 equals 3y add 1. Again, it's a little bit harder to solve, but if I take away y and take away 1, I get 7 equals 2y, and y is 7 divided by 2, which is 3.5. If y is 3.5, then this side is 3.5 plus 8, which is 11.5. The other side will be 11.5 as well, because it has to be. And then the third side is 13. There are the three different possibilities there. Right. Okay. I unfortunately don't have time to do question 13. Don't worry about it. For now, it's a little bit too complicated. But I will say one thing. The line y equals x on a graph I will just say that. The line y equals x on a graph is just like a diagonal line that goes like where the coordinates are the same. So 5, 5, 6, 6, 7, 7, and so on. Right? That is the line y equals x. So that's one of them. And that should allow you to at least do some of the others. Um, yeah, fine. Okay, I need to move on to booklet 3. So let me go through these questions. 3A, 3B. Okay. Draw the graph of 2x plus y equals 7. Right. The easiest way to do this, I'm trying to think of a better way to do this. There isn't really. When you get questions about drawing a graph, what you should try to do is get one of the letters by itself. So if I move the 2x, it becomes minus 2x plus 7. It's much easier to draw this because what you can do is make a little table of x and y, and it tells you to do x from -1 to 4. So -1, 0, 1, 2, 3, 4. And you can use this little formula to figure out what y is for every x value. So when x is -1, for example, -2 times -1 is 2, and 2 add 7 is 9. And then do the same with 0, 0 plus 7. And then you'll end up with these answers, something like that, -1 at the end. And then you can plot those coordinates, like -1. 9 is, oh God, the page, -1, 9. And then 0, 7. And then 1, 5. And 2, 3. And 3, 1. And 4, -1. And so draw a line with a ruler that goes through all those points. That's the way to draw a straight line, generally, with these things. Nope. And then it says, use your graph to find solutions to these simultaneous equations. Well, if you've drawn this line on a graph and you've drawn this line on a graph, the solution to what's called a simultaneous equation is just where those two lines meet each other. And look at that, they meet somewhere. They meet where x is 2 and y is 3. That's it. Okay. Um, 6. Solve the simultaneous equations. Again, you probably haven't done this yet, but probably shouldn't have thrown this into this. Um, would you like to challenge you a little bit? Okay, this is difficult, but I will tell you how to do it. The idea of simultaneous equations is that you try to change either both of these equations so that this number becomes the same. Okay, now 5 and 2, the thing I'm allowed to do is multiply this by whatever I like and multiply this by whatever I like. And the easiest thing I can do is try and make them both 10 because I know how to do that. 10 is a common multiple of 2 and 5. So if I times this equation by 2 and times this equation by 5, what will I get? If you times that by 2, you times everything by 2. So it becomes 10x plus 4y equals 2. If you times this by 5, you times all of it by 5. So the 2 by 5 is 10. Remember, we want to try and make these the same, which I've done. Minus 3 is minus 15y, and 8 times 5 is 40. Once you do that, what you do is you subtract as if it was like a column method and you were taking things away. That's what you do. You do 10x take away 10x, which is nothing. 4y minus minus 15y is 19y because you add. And 2 take away 40 is minus 38. And then you've ended up with an equation that you can solve. If you divide by 19, you get y is minus 2. We're not finished because when you do these questions, you have to find x and y. What you now do is go back to one of these equations. It doesn't matter which one. Let's go to this one. And because you know y is minus 2, you put it in there. If y is minus 2, then 2 times minus 2 is minus 4. You can then add the 4 to the 1 to get 5, and then you can divide by 5, and you'll get x is 1. That is called simultaneous equations. If you can do that now, that's very good. But if not, don't worry. 8b, 9, 12. Jeez. 8. Oh, okay. Don't know what's going on there. Okay, let's read this. Two isosceles triangles have the same base AD, so the AB equals DB, AC equals DC. Fine. Okay, well, the way you do the first part, I understand, because you can work out all of that, and then you can take away um, this much. Okay, fine, that's straightforward enough. Um, okay, that's really hard. Why have you had to do this? Um, right. If you were working out what this angle down here is, then you would do, well, if I said to you this was 20, what would you do to find these two? You do 180, take away 20, and then half it. So to find this angle here, you would do 180 minus 2x, but then you'd divide by 2, and that is 90 minus x. So this angle is 90 minus x, and this angle is 90 minus x. They're both 90 minus x. And then to work out this angle here, you do the same thing, because that's the other isosceles triangle. You do 180 minus x, and you would divide by 2, which is 90 minus a half of x. Okay. And then this angle here, how did we work out before? We took the big angle, which is 90 minus a half x, the blue one, and subtracted the red bit, which was 90 minus x. Okay, it's very horrible, this question. Okay. And then if you expand this, minus 90 minus is plus x. What happens? 90 take away 90 is disappears, and you get a half minus a half plus 1, which is a half x. So what you have done is you have proved that this angle is a half x, which is a half of this angle. And that's what the question asks you to prove. Prove that angle A is always a half of angle x, and you have done so. Um, a difficult question, but this is why we are here. 8b, 9, 12, done 8b, 9. Calculate x. So AB is the same as length AC, so that's an isosceles triangle. Wonderful. Um, which means that all of this is 3x, isn't it? Because AB and AC are the same. So whatever this angle is the same. So all of that is 3x, which means that this little bit must be 2x. Must be. Um, side BD, this is the same as this. Okay. And which means that that's another isosceles triangle, and these two angles are the same. So that's 3x. Now it says work out what x is. Well, these angles have to add up to 180. So 2x plus 3x plus 3x makes 180. How many x's have we got? 8. 8x is 180, which means x is 180 divided by 8, whatever that is. So it's 22 and a half. 13b. Okay, so again, you'll get used to doing these kind of questions, but when you're trying to find where two lines intersect and you have their equation like this, all you need to do is put this equals this. So put 4x minus 10 equals minus 4x plus 18. When it says intersect, think of that as meaning equal. Like where two lines intersect or meet is where they are equal to each other. So put them equal to each other. 4x minus 10 equals minus 4x plus 18. And then you solve this, which you should be able to do, because if you add 4x, you get 8x. If you now add 10, you get 28. And then you get 28 divided by 8. So 28 over 8 is 3.5. That is the x coordinate. X is 3.5. Now, to find the y coordinate, what you do is you take any of these equations and substitute this number in. 4 times 3.5 is 14, pretty sure. Yeah. And therefore y is 4, and that can go here. What's happening here? Right, first one for you. For any number x, add half the number, subtract a third. The answer is x. For any number y, add a third of the number. Okay, add a third of the number. Oh, because you've got three halves. Okay. Right. So if I have a number and I add half of it on, effectively what I've got is three pieces. So if I take away one of the pieces, one third of it, then I am back to what I started with. If I've got a number y and I add a third of the number, then effectively what I've got is four thirds, four pieces, right? Um, if I had a number and I added a third, so I got four thirds. So if I want to get back to what I started with, I need to take off one of these four pieces. In other words, a quarter of the result. I had to think about that for a while. And for any number, add two thirds of the number. So if I've got a number and I add two thirds of it, so imagine they're thirds. If I add two more thirds on, then now I've got five pieces. If I want to get back to what I started with, I need to take off two of the five pieces. So 2/5 of the result. Quite a tricky question. You have to think about it a bit. Um, Oh, geez, that's just silly. Right, for all numbers, show that this is wrong. The reason this is wrong is because if I gave you a bracket to square like that, what you should do is write it out twice and then expand it like this. So you'll get j times j, which is j squared, then j times k, which is jk, and then another k times j, which is another kj or jk, and then a k squared. So what they've missed in this question is the fact that there's this other bit in the middle, which is two of these. It's not just j squared add k squared, it is j squared add 2 jk plus k squared. There's this bit in the middle that that they've missed out. And lastly, how do you do this? Um, right, this is how you do it. Because you have a 12 here, you can kind of assume that the number of beads in this bag are some multiple of 12. Let's pretend, and it can't be 12 because you can't be 12 beads in the bag because the 12 of them are blue and four of them are greens. That already doesn't make sense. So we need to go up in multiples of 12. Let's try 24. Let's say that there's 24 in this bag. If there are 24 in this bag, and 1/12 of them are red, what's a twelfth of 24? It's two. So there could be two of those. If, and we'll see if this works in a minute, but if there's 24 and 12 of them are blue, then half of them are blue. If four of the 24 are green, then that's 4 over 24, right? Which you could simplify if you like. 4 over 24 is a sixth. And if a quarter of them are something else, a quarter of 24 is 6. So that works. I mean, you could have bigger numbers, but that seems to work. 12 add 2 is 14, add 4 is 18, add 6 is 12. There's 24 in the bag. All of these fractions work. And so the key is this number here and recognizing that If 1/12 are red, then there could be 12 or 24 or 36 or 48, and you're kind of going to go from there. And that is the last question. Right, I will stop for a moment. If you have just joined because you are looking for some help with year 10 stuff or year 11, in which we had some quite a lot of paper stuff. Like we just gave you an entire paper, which is quite interesting. Then put your questions in and I will return in just a few minutes. Hello. 14, 15, and 18. From which one? You need to tell me. Is that for the year 10, year 11? But I will go through all of the questions that have been asked there. It's quite a lot. Yeah, 10. It's quite a hard one, right? Because you're doing a full paper, so it's not easy. We tried to balance it with this thing called an intermediate tier, which only some exam boards do, which is kind of in the middle of foundation and higher, so it's sort of okay for you. Um, Question 4, year 10. I don't know what the question 14, 15, and 18 some was. I assume that's the year 10 one, because that's what most of the people seem to be. Right, let's go through some of these. I don't think I've seen these before. Katrin makes the following statement. If you double the length of each side of a rectangle, you will double its perimeter and also double its area. Show clearly how are they correct? Well, why not make a rectangle and just keep some numbers easy, like 4 and 2. Okay, just keep it simple. Right. So the perimeter of this, write this down in here. Perimeter is 4, add 4 is 8, add 2 is 10, add 2 is 12. The area is 8, okay, of that rectangle. Now, shall we double the length of each side of the rectangle and see what happens? So let's make it 8 and 4. What's the new perimeter? 8 add 4 is 12, and then another 12 is 24. What's the new area? 8 times 4 is 32. Have we doubled its perimeter and also doubled its area? We have doubled its perimeter, but we have not doubled its area, have we? So what we'd write now is that when you double the sides, yes, you double the perimeter. So yes for the perimeter bit, but no for the area. The area actually gets 4 times bigger. So perimeter doubles. Oop, doubles. And area gets 4 times bigger. So that's how you do these questions. Like just put in some numbers and try it. 5. Right, 18% of 256 is shared in this ratio. Let's work out 18% of 256 first. That's going to be quite difficult, isn't it? This is a non-calculator, isn't it? Let's make sure. No, it's not. It's a calculator. Right, that's easy then. Okay. 18% of 256. 0.18 times 256 is £46 and 8 pence. It's shared in the ratio 2 to 1. If you're trying to split this in the ratio 2 to 1, what you should do is add these together to make 3, divide by this by 3, which is 1536. And the question is to calculate the value of the larger share. The larger share is the person who gets 2 of these. So times that by 2. And it is 30.72. And this makes things even worse for you. Give your answer to the nearest 10p. To the nearest 10p, that's £30.70. I believe that should be the answer to said question. Everyone should have had this one. It could be that you were accidentally given this one. And if you have been given that one, then it's probably just an error if you're in year 10. But the idea is the year 11s should have got this one, and the year 10s should have got this one. Should have done, but you might have been just in the giving of the papers, it might have been a mistake. So don't worry. Um, what else have we asked? 4, 5, 7. Okay. The diagram shows 2 congruent triangles. Congruent means they're exactly the same, exactly the same. The coordinates are shown. Find the value of A and B. So these are exactly the same triangle. Okay, exactly the same. And we have to figure out what this is and what this is. Okay, so the way I would do it is I would look at these two and see how I go from here to here. So see the x-coordinate here is 3 and the x-coordinate here is 11, which means from here to here, there's a gap of 8, isn't there? And so if we just do the same here, because the same thing has to happen here, there's a gap of 8 between this x-coordinate and this number 2. So 2 take away 8 is -6. So that has to be -6 for a start. Okay. And then also, if we look at the y-coordinates, this was 2 and this is 5, which means the gap here is 3. So the gap here has got to be 3 as well. And if we start at -8 and go up 3, we're on -5. So your answers there must be -6 and -5. Okay, I'm just trying to keep an eye on what has been asked here. Should 4 was asked as well, so I need to go back to 4. I did 4. Okay. Um, 9A. Nth term of a sequence. Okay, this is a quick one. I'll just tell you how quickly you can do this kind of thing. This sequence is going up by 3 every time. Okay. When you have this kind of thing where it's going up by the same number each time, in this case 3, and you have to do this thing called an nth term. An nth term is like a little formula that tells you every single number in a sequence. Or it tells you how to get to any number in the sequence. This is how you do it. Once you know that it's going up by 3 every time, which should be clear, put 3 and then put n. Okay, that's the starting point of your answer. Then what you should do is imagine there was a number before this number. What would it have been? Well, if it's going up by 3 every time, wouldn't that be a 5? And then all you do is you put a +5 there. That's the answer. And what this becomes is like a little formula that tells you any number in the sequence. Like, for example, obviously the next number is 20, right? But 20 is also the 1, 2, 3, 4, fifth number in the sequence. If you put 5 into there, what happens? 3 times 5 is 15, plus 5 is 20. It tells you any number in the sequence. I could work out the 100th number in the sequence. 10, 16, and 18, that's fine. I will make sure I go to that. And then question, I'll be here ages today. 9A and C. Right, a rectangle has a length of x add 5 and a width of 2x minus 3. Well, either way, I'll do it the other way around. That doesn't make a difference, does it? It doesn't matter which way around you write it. Right. Perimeter is 46. Work out what x is. Well, if this side is x plus 5, isn't this side x plus 5 as well? And if this is 2x minus 3, isn't this side 2x minus 3 as well? How would you find the perimeter of this shape? You'd add up all of the sides. So 2x add 2x is 4x, add another 2x is 6x. 5 add 5 is 10, minus 3 is 7, minus 3 is 4. So that is the expression for the perimeter of this shape. And they have told you the perimeter is 46. And then you should be able to solve that from there. So take away 4, divide by 6. Done. 10. Is it possible to draw a right angle triangle with the measurements below? So you may remember a topic called Pythagoras. What does Pythagoras tell you? It tells you that for any right-angled triangle, this side squared plus this side squared equals this side squared. It's like a squared plus b squared equals c squared. You learn that, right? So, and then remember, that only works for right-angled triangles. So if it doesn't work, then it's not a right-angled triangle. So the way I can check if this works, then this side squared plus this side squared should equal this side squared. That is what Pythagoras tells us is true if it's a right-angled triangle. So let's check, does it work? Well, this is where you can use a calculator. The left-hand side says 22.7 squared plus 12.8 squared. So the left-hand side, I've got 679.13. Is the right-hand side the same? No. So let's put a line through that to show that it does not equal. So the answer is no, we can't draw a right angle triangle with these measurements because otherwise, if we could, then it would have worked. We would have had the same number on both of those sides. 11, 12, 13. Basically all of them. Okay, fine. It's weird how this works, right? Some people ask some questions, some people ask different questions. You end up just doing all of it. 11. I'll just tell you these answers. The shaded area of the Venn diagram is this thing here. essentially this little N thing means where they overlap. So it's that. Okay. Um, and then which represents the shaded area, that is this one here. That little line means not. It's called so not B. And what's shaded in this space that you can see now is everything that's not in the B circle. So not B is that basically. Um, 12. Oh, look at the following set of four numbers. Okay. Okay, so we just need four numbers. So the range has increased by two. Okay, the range at the moment that is 13 take away 5. 13 take away 5 is 8. So we want some more numbers where the range is increased by 2, so that we want a range of 10. So the highest number take away the lowest number needs to be 10. Oh God. The mean remains the same. What is the mean? 5 add 8 is 13. Add 10 is 23. Add 13 is 36. Okay, so they add up to 36. So I need another four numbers that add up to 36. If there's four numbers and they have a mean of, well, in this case, 36 divided by 4 is 9, then the other four numbers have to add up to 36. So I need four numbers that add up to 36, definitely. Okay. The median needs to decrease by 1. Okay, what's the median right now? The median is in the middle of these two numbers, which is 9. So the median is 9. So I need the median to be 8. Oh, this is horrible. Right, so I need four numbers. I want the middle of those four numbers to be 8, basically. So the easiest way to do that is just to put a 9 there and a 7 there. Okay, so that's that. The range needs to be 10, and they need to add up to 36. So right now, they add up to 16. So I need another 20. So I've added another 20, and I've also made sure that that take away that is 10. So the situation with these numbers now is that the mean of these numbers is 5 add 7 is 12, add 9 is 21, add 15 is 36. 36 divided by 4 is 9, and that was also the mean of the first four numbers. So the mean has remained the same. Tick. The range has increased by 2. The range was 8. Now it is 15 take away 5, 10. So great. The median has decreased by 1. The median was 9. The median is now 8. And we've done everything. So that's probably how I would do it. Um, there is no algebraic way to do that. I can't. No. Um, no. Sometimes there isn't. I know we always assume there is an algebraic way to do a lot of things, but sometimes there just isn't. And because I think there's just too much going on there for there to be an algebraic way to do it. Because it would involve having like A, B, C, and D, and then doing a lot of stuff. And I think in some ways it's easier to just do what I just did. Um, 12, 13, 15, and 17. 13. Okay. Um, a company has three sites based in Wales. One is in Carno, one is in Holyhead, one is in Porth. Pie charts for 128 female staff and 72 male staff. 128 female staff, 72 male staff. Okay. A person is, well, what I'll do first, actually. See, I can see a few things here. Like, for example, that I'm fairly confident that this is half of this, right? So that's 180 degrees. And if that's 90, that's also 90. Okay, so that's a nice, easy one. This one, that is 180 degrees, right? It looks like it. And that, if that's 120, then this must be 60. So I've just put those in because I'll probably need them. Um, a person is chosen at random from the company's 200 staff members. What is the probability that this person works at the Porth site? Okay. How many people work at Porth is the first thing that we have to figure out. So here we have a quarter of this diagram. So a quarter of these 128 female staff work here. A quarter of 128 is 32. 128 divided by 4. So 32 female staff work there. And for the other one, 120 out of 360 degrees is a third. Um, and so a third of these 72 people work there. It's 24. So in total, we've got 32 add 24 people working at that place, which is 56 people. And if you're picking at random from 200 from all of them, then the probability of them working there is 56 out of 200. And I'd leave it like that. You don't need to simplify because it doesn't say to simplify it. Um, so that's 13. Yep, I'm just going to get through all this. Yes, I'll get through the other paper as well. Question 14. Calculate the size of QPR. You should really be able to do this. This is trigonometry. I don't know. Well, we did do this. We did this in our lessons, I think, recently. QPR means this angle over here. Let's call it X, just for the sake of it. This is a right angle triangle, which means there's a topic called trigonometry for right angle triangles and angles. We have to label the sides. This is called the hypotenuse. This is called the opposite, and the one that's left is called the adjacent. You identify that we have these two sides here that we need to use, and we use that thing called SOHCAHTOA. You identify that it's the O and the H that we care about for this question, so we're going to use this one. That tells you that sine angle equals O divided by H. That's what it means, okay? So in our case, our O is 9.6 and our H is 16.7. Then what you have to do is you use that shift button on your calculator, which gives you this inverse sine thing. It basically separates the X and that. $35.1 degrees is the answer. God. Right. There's a Welsh exam board there, so you get all these Welsh names inside these things. The Morgan family and the Smith family are on holiday in Aberystwyth. There are 7 adults and 2 children in the Morgan family. There are 4 adults in the Smith family. They visit a craft centre. The entry price is X for adults and Y for children. The total cost for the Morgan family is that. Right, okay. So the Morgan family have got 7 adults, a lot of people, each of whom pay this much money. So they will pay 7 times X. And they've also got 2 children, each of whom will pay Y pounds. And in total, they spend £41.50. The Smith family have got 4 adults, so they will pay 4X, and 3 children, so they'll pay 3Y, and their total cost is 29.75. Hopefully you know now what topic this is. So this is a simultaneous equation question. To solve simultaneous equations, what you need to do is make either your x's the same or your y's the same. I'm going to make the y's the same here because the numbers for the x's will get really big. It'll have to be 28 for it to work. So it's easier to use the y's to keep the numbers a bit smaller. So if I times this equation by 3, this will change to 6y. If I times this equation by 2, this will change to 6y. So that's what I want. If I times this by 3, 7 times 3 is 21, 6y, 4150 times 3 is 124.5. If I times this equation by 2, it's 8x plus 6y equals 2975 times 2 is £59.50. Okay, then what you do is you subtract. 21 take away 8 is 13. The y's disappear, that's what we wanted, and 124.5 minus that is 65. I assume the question is to work out x and y. Yes, right. And so x is 65 divided by 13, which is 5. It is £5 for adults. And then what you need to do is go back to one of these equations, like, let's just take this one, for example. Since I now know that x is 5, 4 times 5 is 20. 3y, therefore, is, if you take away 20, £9.75, and y is £9.75 divided by 3, which is £3.25. It is £3.25 for children and £5 for adults. Okay. So understandably, the last parts of these questions will be the paper will be hard. A solution of this equation lies between 1 and 2. Use a method of trial and improvement to find this solution. Okay, what you're supposed to do is try some numbers, basically. So there is some number between 1 and 2 that when you sub it into here, where the x is, you get 0 as the answer. So this is how you do this. You say, okay, I'm going to try that. Okay, so what I'm going to do first, because I know it's between 1 and 2, I'm going to try 1.5. If I do 1.5, then into where x is, then you do on your calculator 2 times 1.5 cubed, that's 2x cubed, plus x, which is 1.5, minus 10. And it tells you that it is minus 1.75. But I want 0, don't I? So this is too small. So I need to try something a bit bigger, like 1.6, for example. If I now just go back to this and just change that to 1.6, it's the way to do this. It tells me that it's minus 0.208, which is, again, still a bit too small. Let's try something a bit bigger. This is what he means by trial and improvement, by the way. And I get 1.5625. And that is too big. So the answer is somewhere between these two. Okay? Because I remember that's one's gone positive, one's negative. Because it only wants to do one decimal place, you can't get any closer. You just need to figure out which of these two is closer to 0. Now, clearly, that is closer to 0 than 1.5625. 1.56 is one and a half away, and the other one is closer to 0. So I would just write 1.6 as the answer now. Actually, I think there is one more little thing you're supposed to do there, but I'm not going to do it. When a number is reduced by 15%, the answer is 6154. What is the original number? If I want to reduce something by 15%, what I could do to that number is multiply it by 0.85. 0.85, because it's 15% less than 1, right? It's like 100 take away 15, isn't it? 85%. That reduces any number by 15%. And so if the answer is 6154, then surely I can figure out what's in this box by doing 6154 and dividing it by 0.85. And it is 7240. It's called reverse percentages. And then a lot of you haven't done circle theorems yet. I think we have a circle theorems lesson coming up next time, so this will suddenly make sense. But just to finish off this paper, there is a rule which you will do soon enough if you haven't already, which is when you have this four-sided shape inside a circle, there is a rule that the opposite angles add up to 180 degrees, which means that x is 180 take away 126. So x is 54. Your reason is the opposite angles in you won't have heard of this if you haven't done circle theorems, a cyclic quadrilateral, that is a four-sided shape inside a circle. The opposite angles add to 180 degrees, and that's why that angle is 54. And then there is another rule, which tells you what y is, which is when you have an arc of a circle from which you make an angle into the middle of the circle, then this angle here is always twice as big as the angle that you make at the edge of the circle, which is the 54. So this y has to be double what 54 is, so it has to be 108. So y is 108 degrees, and the reason is, I'm just going to put it simply, for angle at the center is twice the angle at the edge. Should be sufficient. Right, I want to move on. I assume that's pretty much all of that paper done, isn't it? So going on to the other one, 11, 15, 20, and 23. Will do. Wow. I've got a bad feeling about this. Only in the sense that I don't know if it's possible to do it without a protractor, which I don't have. Um, okay, right. The crucial bit of this is that, which is very unusual to see, because usually it's very explicit in that they're not drawn accurately. These are accurately drawn, which means that I can, and I can't right now, just to be clear, work out the exact area of both of these pie charts because I can draw a line or measure with my ruler the radius. And this is, as you can see, a smaller pie chart. It literally is smaller, right? And the radius here. And I could therefore work out the area here and the area here. And it says the ratio of the number of people is given by the ratio of the areas of the pie charts. So once you have the area of this pie chart and the area of this pie chart, you have a ratio connecting how many people are here versus how many people are here. I'm going to pretend for the sake of argument that it's a 1 to 2 ratio just for now. Um, I'll come back to that last question that's just been asked in a moment. Um, so let's pretend it's twice as big. I don't know if it is because I can't actually measure it with a ruler right now. But if it's twice as big, then once you've done that, you know that there's twice as many people here as there are here. It says what proportion of the total number of people living in these two towns live in Adderley and are aged 0 to 19. Um, what proportion of the total number of people living in these two towns live in Adderley and are aged 0 to 19? Okay. Then what you do is work out this angle using a protractor, which tells you the proportion of people who are 0 to 19 in Adderley, or at least it'll tell you as an angle out of 360. Um, and I'm just trying to make up some numbers here in my head. Let's pretend it's 60 degrees. It looks a bit like 60 degrees. Um, so that if that's 60 degrees, then that represents 1/6 of the people um, there. And then what you could do is use some nice numbers. What proportion of the total number of people living in these towns live in Adderley and are aged 0 to 19? So what proportion? So now what I would do personally is I would use some fake numbers. So for example, I'd say, let's pretend 180 people live here and 360 people live here. That follows the 1 to 2 ratio that the areas would have told me, if that is the thing. I'm just guessing a little bit. And then if they are the numbers 360 and 180, right, then 1/6 of this 360, which is 60 people, live there, which means as a fraction, the proportion of all of the people who are 0 to 19 and live in there, Adley, is 60 out of these two numbers added together. 360 add 180 is 540. And then you can just simplify that, and that would be the proportion. Um, but it will probably be a decimal because I've made the numbers really nice. Um, So yeah, that's impossible for me to do right now, just only because I can zoom in and out of all of this, so I can't actually get an accurate number. But that is how I would do it. Just to quickly go back to see, because that won't take me long. How do you do question 8 in the year 10 paper? Let's have a quick look at that. Oh, Okay. Um, right. So if I am picking a card from this bag, the probability of me picking an R is 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10. That's the probability of me picking an R, right? From this bag, the probability of me picking an R is 1 out of 4. Now, if this person does this 100 times, then if the probability is 2/10 of getting an R, you would expect them to expect, doesn't mean they will, but you'd expect them to get about 20 Rs because it's 1/5 basically. Whereas if this person does it 100 times, a quarter of their letters are R's. They would expect a quarter of 100 to be R's. So they'd expect to get 25, which means that the second person is the one who's more likely to get more likely to get R more often. Um, um, no, because if I want to know the number of different ways of choosing a main course and a dessert, if there's 8 main courses and 7 desserts, you multiply them together. It's 56. And I think for this one, it's 12 times 11 because effectively what you do is you say that each team, if there's 12 teams, plays the other team once. So if there's 12 teams, they play each of the other 11 teams. So you end up with that as the answer. Similar to the question above, really. No, no, it's not similar to the question, but never mind. So yeah, the 12 teams, but what they don't play themselves, do they? So if you take one team, they play the other 11, and then you do so 12 teams each play 11 games, 12 times 11. Question 20. Um, the only way to do this kind of question, when you have to halve it, is they only play once. Sorry, let me just get that right. I haven't checked the answer. I don't think so. I thought you just double it. If they play twice, you double it. But in this case, you don't. I don't think so. I'll have to check the answer. But well, to keep it simple, if there were 3 teams, right, and they each team played each other once, this team would play this team, and this team would play the other team. That's two. Ah, well, you would half it then, wouldn't you? Yes, you'd have to halve it. I assume because you're not counting them twice. Yeah, you have to halve it. So the best way to do that is to just take it with a smaller example like that. So if there's 3 teams, if this team plays this team and this team plays this team, then the only game left is for these two to play each other. Do you see what I mean? Because every other game has happened. So there'd only be 3 games in total because you do 3 times 2 and half it. And similarly, you do 12 times 11 and half it. So yes, I agree. Half it. Um, this question, I think the only way to do this question is to draw a line here. I think this is going to have to be is that going to be the only way to do this? Um, oh, maybe not. OAC is a sector of a circle, radius 10. Okay, I'm going to add some stuff to this diagram that might help. So I have put a 90-degree angle in there because I've told you it's a tangent, and a tangent meets a radius of a circle at 90 degrees. So this is a 90-degree angle, and this is a 90-degree angle. If that's 90 and that's 90, then the angle at the top is, because it's a four-sided shape, 360 minus 120 minus the two 90s, 60 at the top. Yeah, actually, we could have known that anyway. Um, I need one more bit of information. This is so much work. Okay, right. I think I might be wrong, but I think I've figured it out. But there's quite a lot to do here. I think what I need to do is I would like to know how long this side is. And the way to do that, no, that's not how you do it. Okay. Well, let me start doing something that you have to do anyway. So you're going to have to work out the area of this sector. The area of a sector is um, the angle out of 360 times pi r squared, and r is 10. Okay. So it is a third of 104.7, roughly. That is the area of this sector. Now, usually, again, I might be wrong, but usually you also have to work out the area of this triangle here, because what you often need is this little bit here. I'm pretty sure we're going to need this little bit later, because we'll take it away from the triangle above. So to get to this little bit here, I need to work out the area of this triangle, which is easy enough because you do half AB sine C, which is 43.3. So the triangle's 43.3, which means this little bit above, this bit here, which I'm pretty sure I need later, is the difference between this number, which was the whole sector, and the triangle 43.3. So that little bit is 61.4. So now the only thing left to do is to figure out the area of this triangle, which I'm missing something, but as I said, I already know that this angle is 60. If I can work out the area of this triangle and then just take away 61.4, then that's the answer to the question. And I'm just trying to figure out how I do that. Um, okay. Ah, got it. Okay. Um, no, I don't have it yet. Oh, okay. Could have done it a different way. So, hmm. Okay, yeah. I still feel like I can do it my way, but I can't think of it right now. So, what you could have done is drawn a line straight down here, straight, and worked out the area of this triangle, which you can do by first, well, obviously this is 10, and this angle here is 60. So what you could do is actually work out this side now, if you call it um, x. Because of this right angle here, it is the opposite, and this is the adjacent. So you can say tan 60 equals x over 10, and x is 10 tan 60. Which is 17.3. It's actually a third, but it's okay. 17.3. Now that's the area of all of that, which means that the area of the other side is also the same because so if we double it, the area of this entire shape is 34.6. The area of the whole shape is 34.6. And if I now take away this sector that I earlier worked out was 104.7, wait, that can't make, I must have done that wrong. Oh, sorry. Right. I haven't worked out the area yet. So that 10 tan 60 is just the height of that triangle. And so the area of this triangle is a half the base times the height. So a half times 10 times that height that we just worked out. So the area of the triangle is 86.6. Two of the triangles have an area of 173.3. This is the area of the sector here. If I take that away from that, then I'm left with the shaded area at the top. It's dreadful. I think there's another way to do that. I'm still sure there's another way to do that, but that is the answer. And 20, 23. I'll do this last. Okay. No, not easy. The requirement here is to know what is meant by a geometric sequence. This is a geometric sequence because I am multiplying by 3 in this case every single time. Okay, that's what a geometric sequence is. But the other bit that you need to take out of that's in a hard question here is that in any geometric sequence, it must be true that if I take this number and divide it by the number before it, I equal any other number divided by the number before it. Because by definition, I've multiplied by the same thing to keep going on. Um, I did the same thing where I got 60 degrees because I thought in a quadrilateral opposite angles add to 180. That doesn't work if it's not in a circle, but in this case it might have coincidentally worked. Um, but yeah, so because opposite angles in a quadrilateral don't automatically add up to 180. I mean, here is a quadrilateral. The opposite of I don't know what the opposite angles are anymore, but it doesn't automatically work. So in a geometric sequence, the crucial thing is that one number divided by the number before it equals the any other number divided by the number before it. And that's where this works, because if these are the three terms in a sequence, then it must be true in a geometric sequence that this divided by this equals this divided by the number before it. That's the critical thing here. And so if I now cross multiply, so do 1 times 1 is 1, and over here do root x plus 1 times root x minus 1, and expand this out. Square root of x times square root of x is just x. Then I'm going to get minus root x plus root x, which will disappear. And 1 times minus 1 is minus 1, which means x is 2. Does that work? So the first term here is root 2 minus 1. Then it's 1. Then it's root 2 plus 1. Show that the fifth term is that. Okay, I think the only way to do this is to get to the fourth term and then the fifth term. So to get from here to here, if I'm trying to figure out what I multiply by to get from here to here, it would be 1 over root 2 minus 1, which your calculator can actually make it a bit nicer for you because it'll rationalize it. Oh, that doesn't make sense. Okay, it's not root 2 minus 1, it's root 2 minus 1. 1 plus root 2. So we are timesing by 1 plus root 2 every time here. So I think with this one, you don't even need to do anything as a calculator paper. You can just go, well, every subsequent term gets multiplied by this thing here. So if I take this term, so in my answer, I've got my ratio, which I'm timesing by. If I times this by that, it will tell me the next term, which is 3 plus 2 root 2. And if I do on the next term, I want to times that by this as well. By not that, yeah, by this. Seven plus 5 root 2 is the fifth term. That's it. Right, and I will finish by doing 7B in the year 10 homework, if I can find it. Enlargement of a scale. I love this question. Scale enlargement of this using this. Right, I'll tell you how you should do all these questions. Center 1, 2. 1, 2 is there. Right, from the center, what you need to do is write down some directions, and I really recommend you do this, which is write down how you get from here to each of the corners of this rectangle. Okay, so to get from here to here, I'm literally going to write it one right and one up. That's how you get from here to here, right? In terms of squares and units. You go one to the right, one up. Okay, then to get from to this one, you go two right and one up. Then to get to this one here, you go one right and one, two, three up. And then to get to here, you go one, two right and three up. Okay, the reason you'll see why later, why it's good to do this, right? If I'm doing a scale factor of 3, all you need to do now is triple all of these numbers that we get here. So instead of one right and one up, it's 3 right and 3 up. Instead of 2 right, it's 6 right and 3 up. Then it's 3 right and 9 up. Is that right? Yeah. 2 right triples to 6 right and 9 up. So 1, 2, 3. So then you follow these directions from your center. So 1, 2, 3 right and 1, 2, 3 up takes you to here. Then 6 right and 3 up. 1, 2, 3, 4, 5, 6. 1, 2, 3 takes you to there. 3 right and 9 up. 1, 2, 3. 1, 2, 3, 4, 5, 6. There. And you can figure out that that's going to be the last one. And that becomes your rectangle, which has been done like that. The reason why I advise doing this I'm probably not going to have time to do any other questions that has been sent, unfortunately, but I'll try and do them tomorrow morning and send you something. Um, oh, unless I can see them. Oh, yeah, I won't have time to do those right now. But I will get something over to you as soon as I can. Um, so the reason, by the way, I just did this in terms of all this weird stuff here is because the later topic from this is something called negative enlargements with negative scale factors. So you will sometimes see a question where the scale factor is -3 now suddenly rather than 3. So you may ask, what do you do in that situation? Well, what you do in that situation is, you know how I tripled all these numbers here? Not only will I triple them, I will also change the directions. So instead of 3 right, I would have written 3 left here. So 3 up, I'd have written 3 down. 6 left, 3 down. 3 left, 9 down. 6 left, 9 down. And once you do that, then you just follow what I just did at the end, and you will get to the end of the answer. Um, Further maths in the half term. In the Easter, I presume you mean. I think I was doing something. I will get in touch with you about that. I will possibly be able to do something because I think I was running a further maths intensive thing for a few hours in Leeds. And if that is happening, then I will let you know. But either way, I'll find some time to do some further math stuff. So don't worry. I need to figure out my schedule. Right, I think that's it for the time being. Just message us when Easter begins in a couple of days and remind us about that, and I will figure out something with regards to further maths. Um, that's it, I think.